So let's begin with that, right? So stock market prediction problem. So what is the problem? Okay, you already know the problem very well by now. Let me say it one more time. You have to invest in a stock every morning. You have expert advice from 100 different experts. Now you make a decision, and whether the stock market goes up or down, well, that will determine whether your decision was good or bad, right? Now so let me write the steps. So every morning receive expert advice, make a decision, make a yes or no decision. Well, what is expert advice? Yes or no advice, right? So every expert is saying whether you should invest or not in that stock, and then you make a yes or no decision, and then the third part is receive feedback. Feedback is good or bad, right? So was your decision a good decision or a bad decision, or let me call that as, you know, whether you made a mistake or not. Mistake or not. What does that mean? Well, if you decided to invest but if the stock market went down, that's a mistake. If you decided not to invest but the stock market went up, that's also a mistake, because you lost an opportunity to make money. Whereas if you decided to invest and the stock market went up, then that's not a mistake, that's a good thing. Whereas if you decided not to invest and the stock market went down, that's also not a mistake, because you prevented yourself from losing money. So that's also not a mistake. Now, so now what's the goal? Well, the goal is to make money, which means that you don't want to make many mistakes, right? So you want to make as small number of mistakes as possible. Now, to take a simple example, right? So setup, let's make one assumption. What am I going to assume, right? So I'm going to assume there is a stock market, you know, what I'm going to call as a guru amongst your friends. By friends, I mean the experts, basically, right? So you have 100 people whom you are asking for advice, and what I'm saying is that there is one of these 100 people who is a guru, stock market guru, right? So what do I mean by a stock market guru? I mean the following: this person knows whether the stock will go up or down on any day, right? So what does that mean? At 9 o'clock in the morning, that stock market guru will know whether the stock at 5 p.m. in the evening, whether it will go up or go down. And that stock market guru will tell you to invest if the stock is going to actually go up in the evening, and the stock market guru will tell you not to invest if the stock will go down by the evening, right? So it's as if the guru can look at the future and tell you, right? So that's why he or she is a guru, because they know more than what you know, right? Now the problem is you don't know who the guru is, right? Because if you know who the guru is, then what would you do? Obviously you will just follow the guru. You don't need your other 99 friends at all, because you know the guru will always get it right. So you can just follow the guru, and then you can make as much money as you want, right? So every day you will make money. But the problem is, let's say you don't know who the guru is. Now somehow if you can find out who the guru is, then great, you can just follow the guru from that point onwards, and you will never make a mistake ever. Now the question is, in this setup, making the least number of mistakes is same as saying finding the guru as early as possible. Now the question is, how can we devise algorithms which will on every day get these expert advice, 100 different yes or no answers, and somehow make a decision, receive feedback, and over time it should quickly try to identify who the guru is. Remember, you have no other information other than what these experts are giving you, yes or no information, and other than what the feedback you are getting. You don't know anything else about your friends and how they are going to make decisions or anything of that sort. This is the setup, whatever I just described. And in this setup, how should you come up with an algorithm or a procedure that decides to either invest or not invest every single day? And the goal is to make as few mistakes as possible over time. And towards that goal, because of our assumption, that goal is equivalent to saying, I want to figure out who the stock market guru is among my 100 friends, and I want to do this as fast as possible. How will you now go about doing this? This is a very interesting question to think about algorithmically. I'm going to ask you to pause, take some time to think about this, and then get back to the video. And now I will try and explain what might be or what is a good way to solve this problem. But I want all of you to think about this first before you hear me give you the solution. Okay. Let me now tell you what the solution to this problem is. And I'm pretty sure all of you have thought about different ideas. If not, please do that. And now let me tell you how to go about solving this. Let's ask the question, right? So we start afresh. I have no clue about stock markets, whether the stock is going to increase or not. I have no clue on day one. And now I have 100 different friends who are telling me, yes or no. Now, what is the most reasonable thing that I can do? Let's say out of 100 friends, I call up 100 friends and I ask them, hey, tell me whether I should invest or not. Now, let's say 70 of them say invest, 30 of them say don't invest, right? So, day 0, right? So, how many friends say invest and how many friends say don't invest? Let's say 70 say invest, 30 say don't invest. Let's say that's the initial setup. Day 0, day 1. Let's call this day 1. Day 1. That's what happens on the first day. Well, I have to make a decision, and I don't know which experts are good, who is the stock market guru. I have nothing, right? So no such knowledge. I have to make a decision only based on this knowledge. Now, what is the most reasonable thing to do? Well, if 70 people are saying invest and only 30 are saying don't invest, maybe my intuition would say I will go with the majority. And then what I will do is, let's say my decision, let's say then would be invest. That's what I would decide to do. Now, let's say I get a feedback, and this feedback is my decision was wrong, that I made a mistake, right? So, which means I decided to invest, and then at the end of the day stock market actually went down, which means that I lost some money. I made a mistake. Yes, so that's the feedback. That's what the feedback is telling me. But what else is the feedback telling me? Remember, this is a full information setting. Now, how can I exploit the fact that this is a full information setting? The feedback is telling me that I made a mistake. Now, how did I make a investment choice? I decided to invest because 70 people said invest out of the 100. Which means if I am wrong, then all the 70 people who said invest are also wrong. Now, what does that also tell me about the stock market guru? Remember, the stock market guru can never be wrong. That's why he or she is a guru. Now, which means where is the stock market guru out of these 100 people? And what would the guru have said in this round? Well, because I made a mistake and my decision was invest, and the correct decision should have been not invest. And because the stock market guru always gives the correct decision, the stock market guru should be in this 30 people, one of these 30 people. I don't know who, but I know that it is one of these 30 people. Now, how can I use this information to do my decision on day 2? What happens then on day 2? What would you do? Well, what you can do is you can throw away these 70 people. I don't need to worry about their choices from day 2 onwards, because they already made a mistake in day 1, and I know the stock market guru will not make a mistake. So, if I have to find the stock market guru, I only have to care about the 30 people. I will only look at that. I might ask all 100 people, I might get that information, but I will discard the 70 people who are wrong the previous day, and I will only look at the 30 people's answer for day 2. Now, among these 30 people, let us say, right, so among this 30 people, let us say 20 say invest. Let me use the same color. 20 say invest on day 2 and 10 say don't invest. Now, what would I do? Well, again, I will go with the majority, and let us say I will invest. Let us say I do this. Now, let us say I was unlucky again, and then this was also a mistake. Now, what would I do in day 3? Well, I have made 2 mistakes already, but now what I have gained is I have zoomed in into my friend list to figure out where my stock market guru is. Initially, I had no clue. It could have been any of the 100 people. But then after the first mistake was made, I know that it's one of these 30 people. After the second mistake is made, I know it's one of these 10 people. Now, I can keep doing this. And at some point, what would happen is either I have a set of people who are always predicting correctly, or that set will become smaller and smaller and will become a single person. And the moment that set becomes a single person, I know that that single person has to be the stock market guru. And so, I will just follow that single person from that point onwards, and I will never make a mistake furthermore. So, that is the algorithm that we are going to follow. So, the algorithm is very simple, right. So, predict yes or no based on majority of what I am going to call as consistent experts. So, who is a consistent expert? A consistent expert is an expert who has not made any mistake so far, right. So, if an expert makes a mistake at some point, I do not have to consider that mistake expert anymore. I only have to consider experts who have not made mistakes so far, right. So, and I am sure that set will have at least one expert. Why? Because I have assumed that there is a stock market guru. So, which means that I at every round I only predict the majority of the consistent expert. If the majority is yes, then I will say invest. If the majority is no, then I will say no, don't invest. Now, so this is a very simple algorithm, and we can see that eventually it will either figure out who the single expert is, or it will always have a set of consistent experts who will not make mistakes at all, right. So, that set can shrink and become eventually one expert, and at that point I will not make any further mistakes. Now, this is one example of how to develop algorithms for sequential decision making problems, and I hope you found this algorithm interesting. Now here is one question, rather two questions, right? So that I am going to leave you all with, which are very interesting questions, and one of these questions I will let the live session answer one of these questions. The other question we will let you think about that question, and if you really want to know the answer to the second question that I am going to talk about, well, that would be part of a full-fledged data science course. We won't really discuss the answers in this workshop. The first question though is something that you can figure out for yourself based on whatever we have discussed so far. So the first question is, how many mistakes will the algorithm make if there are 100 friends? Remember, if you have 100 friends, how many mistakes can your algorithm make in the worst case, right? So I'm not giving you a specific case where these many people say yes and these many people say no on day one, and so on and so forth, right? So now analyze all possible situations. If you have 100 friends and there is a stock market guru, and I am going to always predict based on majority of consistent experts, what is the worst possible number of mistakes my algorithm can make if I have 100 experts? That is a question for all of you to think about, right? So am I going to make, let's say, 1000 mistakes? Am I going to make 100 mistakes? Am I going to make 99 mistakes? Or am I going to make just 4 or 5 mistakes or 6 or 7 mistakes? I don't know the answer to this, or rather I am not going to tell you the answer to this now. I want all of you to think about this and figure out, in the worst case, how many mistakes can this algorithm make, right? So if you want to make this algorithm make as many mistakes as possible, how many can you force this algorithm to make? That's the first question, and I will let the live session answer that question for you. The second question is, in practice, what is going to happen is there is not going to be a stock market guru. That's a very rare thing, right? So somebody who knows beforehand whether the stock market will go up or not is almost an impossible thing, right? Somebody might be able to predict it reasonably well, but not always. But then in this particular setup, we assumed that there is a stock market guru, but that is not a practical setup. Now, when there is no stock market guru, that is, every expert can potentially make mistakes on one day or many days, how will you change this algorithm, right? So how will you change this algorithm when no guru is present? Clearly, this algorithm is not going to work, right? So because if I am only maintaining the set of consistent experts, at some point what might happen is all experts might have made mistakes in at least one round. So my set of consistent experts, that is the experts who have never made mistakes so far, will be empty. There will be no such expert, and so I don't know whether I will make how to predict at that point. So clearly this algorithm is not going to solve this problem when you let experts make mistakes. Now I want you to think about what would happen in such a situation, which is a much more practical situation. You might really have some friends or experts, and then they are good experts. There are some good experts, some bad experts maybe, but there is no guru per se. Now how would you think about this problem? What are the considerations in this problem, etc.? That's a very subtle, perhaps a little advanced question, I understand, but this is for students who really want to think a little bit more in terms of what is just being covered in this workshop. If you really want to understand the more nitty-gritties of sequential decision making, this is a great place to think about. Okay, so with that, what we will do is we will stop the this module. We'll conclude this module of sequential decision making. So just to summarize, we have seen three different types of sequential decision making problems: full information problems, partial information, and partial information with state change. And we looked at a specific example of full information, which is the stock market prediction example, and we looked at a special case where there is a stock market guru and we developed an algorithm which will work really well under this situation, where it will make very less number of mistakes. And I'll leave you with two questions: how many mistakes will this algorithm make, and how can you adapt this algorithm when there is no stock market guru. With this, we will conclude our module on sequential decision making. There is only one more module to go in this course, which is talking a bit about responsibility in the context of machine learning, and what does it mean to say we are developing algorithms which are responsible. That's a shorter module. I will just introduce some key ideas of responsibility which people are doing cutting edge research on at this point as we speak. I'll meet you again for that module with a different video. Until then, I hope you are occupied with these questions and you find this interesting as well. Thank you.